So we're going to do a little multiplication with fractions today. My first problem doesn't really look like a multiplication problem. It looks like I'm just finding a fraction or a part of 12. I want to find out what number represents 1/3 of 12. Well, some of you might already know that this little word of signifies multiplication when we are taking part of a number. If I want 50% of 12, I can multiply 50% or 50/100ths times 12. Now, of course, every time you see the word of, that doesn't mean we're multiplying. Statue of Liberty doesn't mean statue times liberty. It's just in math when we are using it to find part of a number. Well, what does that mean? It means that if I want you to find 1/3 of 12, that would be the same as 1/3 times 12. Okay, so now, I like to draw models. So if you look at 1/3 of 12, you might automatically think, the whole thing is 12. So let me draw 12 circles. And if I want to find 1/3, that means 1 out of 3 if we remember our ratios. So if I were to shade in 1 out of every 3, you can see that 1/3 of 12 is equal to 4. Kind of looks like a little pea pod there. Okay? But I don't like to do that. We can find a fraction as a part of a group or a part of a whole, but I generally like to find it as part of a whole. Why? Because what if I wanted to find 1/3 of 120? Do I really want to draw 120 circles? No. So this way, I'm going to make my whole is 12. And I want 1/3 of it, which means I want to divide it into 3 equal pieces. And I'm only focused on 1/3 of the whole thing. Okay, now, how do I find what's in each of these thirds, each of these pieces? Well, I know that when I draw a rectangular model like this, all of my pieces have to represent the same thing. So I have to find 12 divided equally among 3 pieces is going to give me 4. And so each box is 4. And as you can see, the shaded part is equal to 4. So 1/3 of 12 is equal to 4. Now, let's look another example. That was sort of easy because it was a unit fraction being a fraction with a numerator of 1. Now let's see if we can do the same thing to find 2/5 of 20, or 2/5 times 20. All right, so let's see. We want 20 is our total, our whole, so the whole thing is equal to 20. My denominator in the fraction, of course, is always telling me how many equal parts are in the whole, so there are 5. So I'm going to divide my whole rectangle into 5 equal pieces, and of course each one of those is going to be 1/5. So I want to shade 2 boxes to represent 2/5. Okay? All the boxes have to be the same, so I have to take 20, divide it evenly among 5 boxes, and that's going to give me 4. Okay, so each box is 4. But look, I have 2 shaded boxes because I'm interested in 2/5, and so 2 times 4 is equal to 8. So 2/5 of 20, or 2/5 times 20, is equal to 8. And so that's how I use a bar. This is sort of a bar model. A fraction model and a bar model are the same. So if you can use it, if you know how to use a bar model for percents, this is great. Now, let's look at this a different way, a slightly different way. Okay, so let's say I want to find the product of, let's say, 30 times what? No. You know what? We're more advanced than that. Let's do 30 times 5/6. Okay? Now, this looks a little different than the other one, especially since I'm starting with 30. Do I have to draw 30 rectangles? Well, let's think about what we know about math that we can apply to this. The first thing we know is we know that the commutative property of multiplication and addition tells us that we can change the order. So if I can't wrap my mind around 30 times 5/6, which it's hard to do, I can change the order, and I can say it's the same thing or equivalent to 5/6 times 30. Okay? All that is using the commutative property to change the order. Now, remember from the beginning that when I take a fraction of a number, it's the same as multiplying. Well, I'm going to use that thinking in reverse, and I'm going to replace the multiplication with the word of. So now I'm looking at 5/6 of 30. And when I think about it like that, I can think, oh, model. Let's model. Okay, whole thing is equal to 30. The denominator is 6, so I have to divide the rectangle into 6 equal pieces. Each one of those pieces is 1/6. I did not label before, but let me just show you that it's always good to label. Okay, I want 5/6, so I need to show that I'm only talking about 5 of those sixths. Okay, now let's figure out what our product is. So I have 30. All the boxes have to be the same, so I have to divide that 30 by 6. And 30 divided by 6 is 5. And if you want to make sure, as you label the boxes, you can count by 5s. 5, 10, 15, 20, 25, 30. So the total here is indeed 30. I have 5 of them shaded. So I have to do, let's show that we're talking about these 5. So I have 5. Well, I have 5 boxes times a 5 in each box, and that is going to be 25. And so I know that 5/6 times 30 is equal to 25. And that's how you use models to find a fraction of a number or to find the product of a fraction and a whole number.